Even reaction is all done.
Yes, ma'am.
Chemistry of E2 we were discussing, right, Manch?
Yes, ma'am.
So have a look. Stereochemistry, if we don't discuss about stereo of E2, so the leaving group should be opposite to the we can say attacking base. That means if we are having halogen and hydrogen, the E2 reaction, what actually happens is that the base is attacked. So elimination, like because the base attacks over here oppositely. Otherwise, if it attacks parallelly to this hydrogen like this, right? If it attacks parallelly like this, so what actually happens is there is repulsion of the base. Incoming base will do the repulsion. This is known as syn-planar elimination. And this is known as anti-planar elimination. Got it? Manch. So anti-planar elimination actually happens, not syn-planar. What happened, Amin?
Yes, ma'am. Only anti-planar will happen.
Let's discuss about how anti-planar. So let us just see that we are having, let's say, pH, CH3, Cl, pH, H and H. So Et, OK, Bt. So which type of alkene we will get? Cis alkene or trans alkene? That is the equation. Let's discuss about it. So first of all, draw it in that Newman projection form.
No.
pH, H, CH3. This one over here I'm writing pH, HCl, HCH3 pH. So if we move these groups, because we want this Cl and the leaving hydrogen to be opposite to each other. So I am just rotating the molecule to 60-degree angles. 60-degree rotation. Cl over here, H over here, pH over here. This H will come over here, pH will come over here, and CH3 will come over here. Now they are anti to each other, right? 180-degree angle between the two. They are anti. So now we can remove this okay. We can easily remove it out. We will get this type of framework. pH, H, CH3 and pH. Right or no?
Whenever the removing group should.
That is the reason we can convert the formed alkene to be like this. pH on one side and CH3 and H on one side. Like this. Got it or no? So this is cis alkene which is formed by the elimination over here, not the transfer. Alright.
Yes, ma'am.
So let's say we are having this type of structure. So we need to eliminate. Now the point is this X will eliminate definitely, but it requires the hydrogen, neighboring hydrogen. This is also beta hydrogen, this is also beta. It requires beta, but this beta is on wedge or dash.
Dash now.
So this is on dash, so it requires hydrogen to, that is eliminated. It should be on wedge position. Got it? Hydrogen should be on the wedge position. So there hydrogen is on dash, so it cannot participate. So that is the reason we are now taking this hydrogen, and we are getting this type of element. Is that clear to you or no?
I mean, so because it's on the dash, that's why we remove this hydrogen, no?
Hello?
Ma'am, because this is on the dash, that is the reason why we are removing it, ma'am, yes.
Okay? Got it now?
Ma'am, why ma'am we are removing that hydrogen only, ma'am, that some doesn't dash wedge position?
Anti-elimination is happening, na? Anti-elimination means hydrogen and leaving group should be anti to each other, opposite in plane to each other.
Ma'am, when we need to consider this anti-elimination?
Always when we do the elimination, you need to make E2 mechanism happens, we have to consider anti-elimination. If it is E2 reaction, anti-elimination, you have to consider.
I mean, when the rate is 2, then one should consider it as.
Correct. Okay?
Yes, ma'am.
We didn't started even reaction or we did? Started E2 only, na? Then let's discuss about even reaction. Given reaction is like so we're getting alkene, but let's discuss about the mechanism of this reaction. So mechanism is like so first of all we will get a carbocation. By the removal of this X, we will get a carbocation. This is step 1. We are getting a carbocation. In step number 2, this formed carbocation will attack over by base. Base will attack to H and ultimately it will cleave the bond and form a double bond. So the rate depend on the slow step. Always remember, whenever carbocation is forming, that step is slow only and that is the rate determining step. So rate is equals to K into only one, that is concentration of alkene halide. So that is why we will say that the order of the reaction is 1 and molecularity is also 1. Got it or no?
Ma'am, why ma'am only we are saying carbocation? Why can't H plus and C minus can be formed?
H plus and C minus. There is a little electronegativity difference in between the two. The bond is not having that much polarity as the bond between carbon and hydrogen was there. That is why X, and because the bond that is having more polarity will easily break. No?
Yes.
So that is why electrons are free, you can say, shared equally between the two. But here, in carbon halogen bond, the bond is having very much high polar characters. That's the reason.
Due to more electronegativity difference.
What happened, Iman?
Got it, ma'am.
The profile diagram. The energy profile diagram is like this is a reactant and this is product. And over here this is the carbocation. This is transition state first and this is transition state second. So since intermediate is carbocation, so there is some chances of rearrangement can happen. Remember rearrangement? Iman, we already did the rearrangement, na? Rearrangement.
Yes, ma'am.
Is that clear?
Yes, ma'am, clear. Ma'am.
Let's continue the considering content. It. So let's say this reaction is doing even mechanism. So how many products are possible? Number of isomeric products. That's the question. So you will remove the Cl out and you will get a carbocation. Now either this carbocation produce a double bond like this or produce a double bond like this, right? But there might be the chances of rearrangement. 1, 2, hydride shift. It can happen over here. So it seems to be like carbocation over here, hydrogen over here, right? Now this carbocation is 3 degree, which is more stable as compared to the prior, which is 2 degree. Now you can again remove the double bond and you can create a double bond like this or create a double bond like this. Right or no? But if you take a look that these two are same only. So there are total 1, 2 and 3. So these are 3 isomeric products. Can be formed. Got it or not?
Ma'am, in the first case, this hydrogen bond shifting to that between two carbons. Ma'am, why? Ma'am, how that first product will be possible, ma'am, genuine?
This one, the possibility is that, like, although it's very little, but yes, this first structure is formed. Although very interest amount we can say, right? But there is probability of forming the structure.
Ma'am, but even if this hydrogen bond shift to that, again this bond is shifted to the next carbon, we are saying, ma'am.
Sorry.
Ma'am, this hydrogen bond is shifting to this adjacent bond and forming a double bond, now, ma'am. We'll get second product now, ma'am.
Yeah. No. While the carbocation over here, there is two possibilities. Either we can remove this hydrogen and create a double bond over here, or we can remove this hydrogen and create a double bond over here. So these are the two possibilities without rearrangement. This one is major and this one is minor. But the point is that if we do the rearrangement, then we will get another type of carbocation. Now we can again with this carbocation remove the hydrogens and we will get a double bond in the positions like this. Got it?
Ma'am, according to which rules we are saying it's major and it's minor, ma'am, again?
Has that rule enough?
Only according to those rules only we should specify.
Has that rule more substituted? This is more substituted, this is major one.
Yes, ma'am.
Right? Any problem, any doubt if you wanted to ask, you can tell me.
Ma'am, no problem. No good.
Another example, if you want, we can do one more example. Let's say this is the alkyl halide, right? Neat. Now what we will do? Number of products, Imanch. Okay, can you tell me how many products you can create? Do we try it or no?
No, yes. No, one product with double bonded on.
No, I'm just asking for you the overall number of double bond, number of products. How many different possibilities can you create?
One product. Man, three possibilities can be there now.
Now, I'll explain.
Yes, ma'am, can you explain? It's only single.
So Cl elimination will get this carbocation. After we getting this carbocation, there is, we can say two, one double bond over here, another double bond over here, right? But this carbocation can do ring extension. Due to ring extension, we will expand the ring like this, creating it to be six membered now with a double bond with a methyl group over here and this carbon getting a positive charge, right or no?
Yes, ma'am.
Hmm. So accordingly, we can now form again two types of double bond. One over here and the second one over here. Right or no?
Yes, ma'am.
Then we can do a rearrangement also over here. 1,2 hydride shape like this. They'll get a new type of carbocation. This one. So we will get a double bond one time over here and another time double bond over here. And they two are same only. So 1, 2, 3, 4, 5, 5 products are possible. Got it?
Yes, ma'am. Again, this plus will go there, and that's why these five products are getting formed. We can say.
Huh? One second, one second. If we include the stereoisomer over here, na? This is stereogenic center, isn't that? Right, Manch?
Yes, ma'am.
Since it is a stereo center, we will say that these are two in number, right?
Yes, ma'am.
One, two, three, four, and this will be five. And this shift six. These two are same, got it? Next, moving on to another type of reaction. Also remember, leaving group is to be like good leaving group. According to leaving group, the reactivity rate is iodine, then bromine, then chlorine, and then fluorine. Okay. And that alkyl halide is also like according to alkyl halide, it is like 3 degree, then 2 degree, then 1 degree. Due to stable carbocation they are forming. Na? Use elimination. Whenever you are finding any problem now, just ask me.
Yes, ma'am.
Unimolecular conjugate base. So first of all, conditions. When it can do even CP reaction. The first condition is beta carbon have acidic hydrogen. Acidic hydrogen. Leaving group must be poor. Leaving group must be poor. Leaving group. Like fluorine, OH, SR2. Got it? Positive. These are poor leaving group. So what happens is Z, let's say we are having Z, CH2, CH2, X. So it's alpha. This one is beta. Alcoholic KOH. Can you see the beta hydrogen over here? That beta hydrogen is having hydrogen that is acidic hydrogen. Alright.
Ma'am, acidic hydrogen means what is its meaning? I didn't specify.
Acidic hydrogen means the hydrogen that is easy to remove out. Why is it easy to remove out? Because after its elimination, we can say that the group is Z group is having ability to withdraw that electron density, like the carbon ion which is formed over here by hydrogen removal is getting stable. That's when H removes out, Himansh. Acidic means acid are the one that removes hydrogen, right or no? Tell me this thing. Acids are the one that removes hydrogen. So Z group removes Z groups. Z group is the group that should showing, we can say, electronegative effects like chlorine. Z group is the group that contains even minus R or minus I effects, due to which, like carbon an ion which is formed after the hydrogen elimination, because alcoholic KOH, it's a base. Base will remove the hydrogen from the beta carbon. If hydrogen is removed out, H positive removes out, carbon got a negative charge. That negative is being attacked by the Z, which is electronegative. Getting it or no? I will explain you, no issue. Just look into the reaction and you will get the answer about it. X and H both of the removes. The mechanism is like Z, CH2, CH2. This one is alpha and this one is beta. Now, what happened is OH negative. It's a fast eliminator. The action is very fast. So instantly it removes the hydrogen from the beta carbon. So we are getting what? Z, CH having a negative charge, CH2 connected to X. Now Z, what is Z? Z is an electron withdrawing group. So it stabilizes the conjugate. This is the conjugate base. It stabilizes the conjugate base. This is the conjugate base.
Means whenever Z is minus R and minus A groups, then it's attracting electrons. So hydrogen has H plus character. We are saying that character as acidic hydrogen. We are saying.
Now this is attacking over here and X comes out. So we are getting Z, CH, double bond CH. It's a poor living group, right? So here the rate depends on over here on alkyl halide and as well as base. Both. Order is 2, but molecularity is 1. That is why its name is even CP reaction. Got it? Himansh.
Yes, ma'am. Got it.
Now let's take this example. This is a poor living group. OH is very poor living group. And this is electron withdrawing group. This is alpha carbon and this is beta carbon. Beta carbon contain electron withdrawing group. So we will say that when we attack alcoholic AOH and when we heat it, we will get what? Double bond O living group removed out and we'll get a double bond over here. Right? So for even CP to proceed, we require a poor living group and electron withdrawing group on the beta carbon. Right? Man, is it clear?
Yes, ma'am. Clear.
Or you can write it like this. So this is electron withdrawing group. It's a poor living group. It's electron withdrawing group. Present on this is alpha and this is beta carbon. So you are just adding this and what you are getting now? Fluorine and okay over here and we are getting a double bond like this. Similarly CH2, CH2, CHCl2, CHCl2, CH2F. Again this is a poor living group. So it will remove out and this is hydrogen is acidic hydrogen on the beta carbon. So we are getting CCl2 double bond CH2. Is that clear to you or no?
Yes, ma'am. Clear, ma'am.
Fourth point. D. Before the elimination, but we did discussed about elimination reaction no? So far. We are discussing elimination only, no? Himansh?
Yes, ma'am.
And we did halogenation, hydrohalogenation, correct? And we created that alkene from that. This was the part going on. Alkyl halides. Now let us discuss about from another type of second type of reaction, dehalogenation. Dehalogenation of vicinal dihalides. Vicinal dihalides. So what is the meaning of first of all vicinal dihalides? This is X. This is also X. Zinc, heat, CS3COOH. We are getting a double bond like this, right? Also, NaI, sodium iodide, acid. Very important, well known. So again, we are getting this double. Okay, is it clear? Vicinal dihalide means the neighboring carbon contains halogen. That is the meaning of vicinal dihalide, Himansh.
Yes, ma'am.
Moving on to another concept, that is, first of all, the reaction over here is happening. The elimination is happening over here. The mechanism is E2 mechanism happens. And can you tell me in E2 mechanism, stereochemistries?
Why, ma'am, here only E2 will happen, we can say? Because order is 2, that's the reason.
I'll explain the mechanism. That is stereochemistry is antiplanar. Antiplanar. Let's discuss the mechanism to better understand the concept, what is happening over here. Mechanism. Mechanism is like okay, antiplanar. So here what actually happens is, see, zinc 2 positive and 2 electron. That zinc 2 positive approaches this X. With the 2 electrons. Give the electron to X. X will transfer it over here and this X will ultimately remain out. Got it or no? What actually happens? Zinc is having that electron to donate, na? 2 electrons. So these 2 electrons will it will give to X. X will take the electron of zinc, right? And when it takes the electron between carbon and X will be transferred to carbon-carbon. When this carbon takes the electron, ultimately it will break a bond with X. Got it or no? Manch.
Means this X will. Ma'am, means homolytic fission goes on and C radical and X radical forming, and this and X
It's
will.
not homolyte. It's not homolyte. It's different. Homolytic is the case now, we will show this type of arrows. Right? But this is not homolytic.
Ma'am, means we can say like ma'am. Ma'am, and C X minus C plus forming, and these two electrons going to that root C plus, and a bond is forming between them. That's the
X minus, oh, it's X positive.
exposite.
Yeah. See, like what happens is C and X bond breakage happen, but the bond breakage is in different manner. Like zinc donated its two electron to X. So the X will get that electron from electrons of zinc. Ultimately, since X is getting the electron so now carbon X bond breakage happen where X will not take the electron of carbon. It will donate the electron to carbon now because X is already getting the electron from zinc, right? Or no? Manch.
Yes, ma'am.
Thank you.
Because there are two electrons available, it gives its electron, and positive gets converted to negative by accepting two electrons. We can say.
This is how X is in negative form now. Negative combines with Zn X2 will form over here. That electrons of carbon halogen is transferred to carbon carbon, and when the carbon create a new bond, ultimately X will be moved out. Got it?
Ma'am, here two C negatives will form, and both will form a bond by giving one each electrons. We can say.
How to see negative will be formed over here?
No, one lower halogen and upper halogen both.
It's like upper halogen is leaving out in the form of X negative. I'll explain you once again about it. Like this. So here carbon and halogen bonds break to be like this. Carbon is getting that electron. X getting a positive charge. You can show it with like carbon getting a negative. It's carbon. Halogen getting a positive charge. That positive is taking two electrons now. When one electron taken, it becomes neutral. When two electrons taken, it becomes negative charge.
Yes, ma'am. Lower one.
Right?
Yes, ma'am. This one I understood.
Now, this negative is making a bond over here. When a new bond is created, this carbon got an electron now, so halogen leaves out X positive. It is X positive, X negative now. Second X negative.
Ma'am, means this carbon will give its extra electron and form a bond between CC.
So these two X negative will combine with zinc and form zinc 2 positive and form ZnH.
Ma'am, means here that upper halogen will go X negative, and C positive will be formed, and the C positive negative will form bond, and alkene is formed by same.
Correct. Although these reactions are not in the multiple steps, it's a single step it's carrying on. All the steps are occurring in the same way. Alright.
Yes, ma'am.
Is there any doubt? Yuvansh?
Out life.
Ma'am, no doubt. Got it, ma'am. Yes,
Similarly, iodine minus will also do the same thing. Like we did taken two examples. In first we are zinc heat CH3COOH. In the second one it's NaI acetone. So here also this again same procedure is happening. I minus attached to this, it will move the electron over here. When this carbon gets it, X will remove. See, we are giving that electron to X. X give the electron to carbon. Carbon give to carbon, carbon double bond. This carbon will give the electron to X. So ultimately we are getting carbon double bond carbon. Right? NaX, IX. Got it? Or no?
Yes, ma'am.
And this is also always remember it is anti-member. So let's say they given you the structure to be like this. VR, CH, CH. Right? So zinc P, CH3COOH, that's it. So now you have to first of all arrange it in human form. PH, VR, CH3, PH, VR, CH3. You have to rotate it to 180 degree like this. So you will get it to be VR over here, CH3 over here, PH over here. This VR goes over here. CH3 will be over here. PH will be over here. VR and VR eliminate out. You will get an alkene. PH, CH3, CH3, PH. So you can simply see that PH and PH are 180 to each other. They are 180 to each other. That means we are getting a trans alkene. Right? This is a trans alkene we are getting. Is that clear to you or no, Himansh?
Yes, ma'am. Clear, ma'am.
Next is by dehydration of alcohols. Now again this topic is very much important. So we are having alcohols. OH and H removes out. So any type of acid. Concentrated H2SO4, K2SO4, H3PO4. Not heat or T2O5, T4O10 or Al2C2. Right? So they are huge. All of them will do the same function. They will create an alkene like this. Okay? So simple procedure is 1 degree alcohol, go with E2 mechanism, and 2 degree or 3 degree will go with E1 mechanism. Right or no?
Ma'am, in the previous example, ma'am, why only E2 you said, no, ma'am? E2 will undergo.
See, because it's only incoming, we can say either zinc or iodine that initially attacks, then only the bond breakage happens.
Ma'am, generally, ma'am, for a reaction which will occur, how can we say, ma'am, like it will be E1 or
You
E2?
have to check that whether, yeah, E1 or E2, you just have to check that whether the elimination of a group will creating a positive carbocation. So you have to see that whether you are getting a stable carbocation or not. If you are getting a stable carbocation, you will go with E1. Okay. In the previous example, two halogens was there. Right, Naiman?
Yes,
Huh?
ma'am, two halogens are there, ma'am, in the previous.
So the reaction only proceeds because two halogens are there. If you remove one halogen, you will get a carbocation. And that carbocation is unstabilized by second halogen due to minus I of it. Got it? Or not? Manch?
Yes, ma'am, two halogens.
So that is the reason when we are having vicinal dihalides, we are going with E2 mechanism.
So because for the formation of carbocation, they get stability. That's the reason. Yes.
So even we have to check that whether the stability is there or not. Because if we form the carbocation, we have to check that whether the formed carbocation is stable or not. That's it. Right now?
Yes, ma'am.
Hmm. So the mechanism and all, we have to discuss the mechanism and all. How the mechanism is going on of this reaction. Let's say we are having a carbon OH attacked by an H positive, that is an acid. Oxygen contains lone pair. H positive is electron poor, so oxygen donate the electron to this and create OH2 positive carbon, and like this. Since oxygen bears a positive charge which is unstable for oxygen because it's an electronegative atom, it will eliminate in the form of water. And we are getting carbocation in the position of it like this. Right? So this step of formation of carbocation is slow and reversible. Right? And ultimately, this is carbocation that is forming over here. And ultimately, you are removing the hydrogen out and you are creating an alkene like this. This is first. Is that clear to you or no? All the process are reversible. What happened, man?
Yes, ma'am, clear, ma'am.
This is through E1 I'm showing you, na? Yes, carbocation which is forming over here. So rearrangement is possible for this. We are getting 1, 2, 3, and 4. So the energy profile diagram for this structure to be like alcohol over here. This one, alcohol. Then we are getting ROH2 positive. Then we are getting this carbocation. Then we are getting this alkene. So these are the products we are getting. So we have to follow the this is transition state first. This is second, and this is third. Where the bond they see here in these all these are actual structures. Right? Transition states are one where temporary bonds are being created. Got it? Manch.
Yes, ma'am, got it, ma'am.
Now we will discuss about the next part in next class. That's it.
Yes, ma'am. Okay, ma'am.
And are you free at 2 o'clock?
Yes, ma'am. I'm free, ma'am.
Huh?
Yes, ma'am. I'm free, ma'am. At 2 o'clock.
We can continue the second class at 2 o'clock. Okay.
Yes, ma'am. Okay, ma'am.
Yeah. Also, I create your one class of yeah, okay. 10 class more. We have to create 20 class, no?
Yes, ma'am.
10 class more, and one more class that was missed because I have created 10 classes so far, but
Yes, ma'am.
I'll
Okay,
create
ma'am.
one more class that was missed yesterday. Okay,
Yes, ma'am. Okay,
so
ma'am.
that's how from today itself, and you have to pay me 2500
Yes, ma'am.
for these classes. Okay,
Yes, ma'am.
okay.